What is heap sorting? Heap sort is a popular comparison-based sorting algorithm. It works by building a binary heap data structure and repeatedly removing the largest for ascending order or smallest for descending order element from the heap and placing it at the end of the sorted array. This process continues until the heap is empty, resulting in the sorted array. Heap sort has a time complexity of O n log n, making it efficient for large data sets. Importance of heap sorting. Heap sorting algorithms hold significance in computer science due to their efficiency and ability to handle large datasets. They are especially valuable for applications where you need a stable and predictable sorting method. Heap data structure. A heap is complete binary tree, meaning all levels of the tree are fully filled except possibly for the last level, which is filled from left to right. The two most common operations on a heap are insertion, adding an element, and removal, deleting an element. These operations maintain the heap property.
Max heap. In a max heap, for any given node 1, the value of 1 is greater than or equal to the values of its children. In other words, the maximum element in the heap is at the root. This property ensures that the largest element is always at the top, which is useful for tasks where you need to retrieve the maximum element quickly, such as in priority sweep. In a min heap, for any given node 1, the value of 1 is less than or equal to the values of its children. The minimum element is at the root. A min heap is useful when you need to retrieve the minimum element efficiently, as it's always located at the top. Stability. Heap sort is not a stable sorting algorithm. Stability means that the relative order of equal elements remains preserved after sorting. In heap sort, equal elements can change the relative order during the sorting process, making it unstable. Comparison with other sorting algorithms. Quicksort. Quicksort is also an efficient sorting algorithm with an average case time complexity of 0 or n log n. However, it can be less predictable in terms of worst case time complexity, 0 n to the power of 2. Quicksort is generally faster in practice than heap sort due to its lower constant factors. Merge sort. Merge sort is also stable and has a time complexity of 0 or n log n. It's known for its consistent performance and is often preferred when stability is required. Insertion and bubble sort. These are less efficient algorithms with average case time complexity of 0 n to the power of 2. They are simple but not suitable for large datasets compared to heap sort. Application where can heap sort found? It's important to note that while heap sort has its applications, other sorting algorithms like quicksort and merge sort are often preferred in general sorting scenarios due to their better average case performance. Heap sort's primary advantage lies in specific use cases where you need an in-place sorting algorithm with a stable time complexity, such as maintaining priority queue or finding the kth smaller or largest element.
Operating system schedulers. Operating systems often use priority queues implemented as heaps to manage processes and tasks. Heap sort can be used within these schedulers to efficiently maintain the queue of processes based on their priority levels. Memory allocation. Memory management systems may use heap sort to allocate and deallocate memory blocks efficiently. The heap data structure is used to keep track of available memory blocks, and the heap sort can be applied to organize this heap. Network routing algorithms. Some routing algorithms in computer networks utilize heap sort to select the most suitable path for data packets based on various criteria such as latency or cost. Selection algorithms. Heap sort's ability to efficiently find the smallest to largest element in a dataset is used in various applications including statistics, databases, and data analysis. Simulation and modeling. Simulations and modeling scenarios. Heap sort can be used to maintain event queues efficiently, ensuring that events are processed in the correct order based on their timestamps or priorities. Online gaming. In online multiplayer games, heap sort can be used for managing player rankings and leaderboards, where the leaderboards need to be updated dynamically as player scores change. Advantages and disadvantages. Advantages of heap sort. Efficient average and worst case time complexity. Heap sort has an average and worst case time complexity of O n log n, making it efficient for sorting large datasets. In placing sorting, heap sort sorts the array in place, meaning it doesn't require additional memory for sorting, unlike algorithms like merge sort. Guaranteed worst-case performance. Unlike quicksort, which can have a worst-case time complexity of O n 2, heap sort's worst-case performance is consistently O n log n. Stable space complexity. Heap sort has a stable space complexity of O1, making it suitable for scenarios with limited memory. Disadvantage of heap sort. Not stable. Heap sort is not a stable sorting algorithm, meaning it can change the relative order of equal elements in the sorted array. Slower in practice. While heap sort has good theoretical time complexity, it can be slower in practice compared to algorithms like quicksort due to its higher constant factors. Not adaptive. Heap sort's performance is not adaptive. It doesn't take advantage of pre-sorted or nearly sorted data and always runs in O n log n time. Complex implementation. Implementing heap sort correctly can be more complex compared to some other sorting algorithms like bubble sort or insertion sort.
Hello guys, and we're at the group 9, and now we're discussing about heap sorting algorithm. So, ang ginawa ko po dito first is use import, and we saved this Java code by heap. So, secondly, we're going to make public static void heap sort. And R. R is for ano po ito? Array. So this line declares a public static method called heap sort, which takes an array of integers as input and sort it in ascending order using the heap sorting algorithm. Then we're going to add then we're going to add m equals to array semicolon. So this line declares a variable called n and assigns it the length of the input array. Now, next is for m I is equals to n slash 2 minus 1. 2 minus 1 semicolon I is greater than or equal to 0 semicolon I double dash and lastly heapify or this loop builds a max heap from the input array. A max heap is a complete binary tree where the parent node is always greater than or equal to its child's node. The heapify method is used to heapify a subtree rooted at a given index. Next is for n I is equal to n minus 1 I is greater than 0 semicolon I double dash. So int temp is equal to array 0 semicolon array 0 is equal to array I. Array I is equal to temp. And then we're going to call max heap by on reduce heap. So heapify array I 0 So this loop extracts elements from the heap one by one and places them at the end of the sorted array. The rooted element of the heap is always the largest element, so it is placed at the end of the sorting array. After the root element is extracted, the heap is heapified to maintain the heap property. So next, we're going to add public static void heapify in r and m and I and largest, so I semicolon and left child is equal to 2 times I plus 1 plus and right child is equal to 2 times I plus 2 semicolon. So if left child is stop yan and array left child is greater than array largest. So largest is equal to left child tapos naman if what if right child is lesser than n lesser than n, and array right child is greater than array largest. So largest is equal to right child semicolon and thirdly, if largest apostrophe I equal I, and swap or I array I is equal to array largest. Array largest is equal to swap. Okay. And then we're going to add heapify array and largest. And so this method heapifies a subtree rooted at a given index. It works by comparing the current node with its left and right child nodes. If either of the child nodes is larger than the current node is swapped with the larger child node. The heapification process is then recursively applied to the subtree rooted at the larger child node. Yep. So now we're going to add more. Public static void main string args scanner sc equals new scanner system.in and array equals to new int 6 for int a is equal to 1, then a is less than array dot length, then semicolon a plus plus brackets system dot out dot println print lang pala number plus a plus quotation marks semicolon array a is equal to sc dot next int system dot out dot print original array So, dito lalabas ang ating code. Version array print array r semicolon. Lagyan natin ng heap sort array system.out.print sorted array print array r. Yun. So, this is the main method of the program. It creates a new array of integers and prompts the user to enter 6 integers. The array is then sorted using the heap sort method. The heap sorted array is then printed to the console. So lastly, public static void print array int array brackets or value array brackets system.out.print value plus system.out.print and spacing. So, ito na. Errors. Error 17. Where is the error? If I